Students, our next question is an important one now. Look at the question written on the board. You have, if y is equal to sine rx plus cos rx, then prove that yn is going to be r raised to n. In a bracket, you have 1 plus minus 1 raised to n sine 2 rx whole to the power 1 upon 2. And also he is asking to find the value of y8 when x is equal to pi when r is 1 upon 4. Now, the next question is an exact copy of this particular question. The only difference that you can observe in the two questions is the writing pattern. You can observe here y is equal to sine theta plus cos theta, and what is theta given to us? It is rx. So it is the same thing, y equal to sine theta plus cos theta, just the value of theta is rx. So rx is simply replaced by theta, and you want to prove that the nth derivative yn is coming r raised to n, one and the same thing, 1 plus minus 1 raised to n sine. You have 2 rx. Rx is taken as theta, so you can see here sine 2 theta, and this entire bracket raised to 1 upon 2 is given to us. You can observe that both the questions are exact copies of each other. The solution is definitely going to remain same. Now, in this particular question, students, the nth derivative that I'm going to apply is only in one step. That means the successive differentiation part is going to be very easy. What is going to be the critical part is getting the prove that statement. This is going to be an important one. You want to get the prove that statement very properly here. So lot of trigonometric formulas are going to be involved into this particular question. So let's begin with the solution. So I have to get nth derivative. I have y. So let's first of all write what is y given to us. So students, I have y is equal to sine rx plus cos rx, isn't it? You have y is equal to sine rx plus cos rx. I need to find the nth derivative, so I need to get yn. So let's differentiate both sides n times with respect to x. So let's differentiate both sides n times with respect to x. So I'm going to get yn. So therefore, yn becomes equal to. We know that the nth derivative of sine ax plus b is a raised to n sine n pi by 2 plus ax plus b. And similarly, the derivative, the nth derivative of cos ax plus b is a raised to n cos of n pi by 2 plus ax plus b. So here I have a term of sine rx which is looking like sine ax plus b. I have another term of cos rx which looks like cos ax plus b, and in between I can see there is a plus sign. That means I can definitely use the u plus v rule for the nth derivative as well. So my answer is going to be r raised to n for sine of ax plus b. A is r, b is 0. So I get a raised to n. So here I get r raised to n. R raised to n sine of n pi by 2 plus rx, isn't it? And then plus for cos rx, what is the nth derivative that is going to be written over here? It is r raised to n cos of n pi by 2 plus rx, isn't it? Now you can very easily understand that the r raised to n can be simply taken out common from the two terms. So my next step is going to be yn is equal to, you have taken out r raised to n common, isn't it? Now for some time, is it okay to call this n pi by 2 plus rx as say phi? I'm not going to make use of theta because if I take the solution for the second question, theta is already involved into the question, so I cannot make use of the symbol theta. So I'm using phi. So n pi by 2 plus rx, this I am writing for some time phi. So this is also n pi by 2 plus rx. So this will also be written as phi. So I have taken out r raised to n common, n pi by 2 plus rx, this term has been replaced with phi. So my next step will now be looking something like this. I have r raised to n sine phi plus cos phi. Now you can observe I have got my nth derivative and it is nowhere close to what he's asking me. I can see that there is r raised to n. I have got r raised to n. But look at the term which is present inside the bracket. You need to get 1, then plus, then minus 1 raised to n, then sine, and the angle is also different. It is 2rx. Here you have got n pi by 2 plus rx. So angle is totally different. The terms are also not matching. That means your answer, the nth derivative that you have got, is nowhere any close to the nth derivative that is asked in the question. That means now you need to start thinking slightly different over here. Now look at the bracket, the power to the bracket. The power to the bracket is given to us as 1 upon 2. Here the bracket has power 1, so your first job is to get that power 1 upon 2. So students, I'm going to make use of the formula. Observe carefully. These are very important formulas from trigonometry. It's called as a half angle formulas. So I'm going to write the formula over here. Observe carefully whether you recall it or not. So if you recall, there is this formula 1 plus sine 2 phi. It is cos phi plus sine phi the whole square. Now it does not matter whether you write cos phi plus sine phi or you write sine phi plus cos phi. It is exactly one and the same things. So that's the formula for 1 plus sine 2 phi. Likewise, students, if you recall, the formula for 1 minus sine 2 phi, it is going to be cos phi minus sine phi the whole square. Again, here also, whether you write sine phi minus cos phi or you write the same one cos phi minus sine phi the whole square, it is not going to matter, because students, a minus b the whole square and b minus a the whole square are going to give us the exact same answer. Getting or not? So here cos phi minus sine phi or sine phi minus cos phi the whole square does not matter. So now you can observe this is sine phi plus cos phi. Look at this, sine phi plus cos phi the whole square is 1 plus sine 2 phi. So this whole square, if it goes on the other side, becomes what? It becomes square root, and square root is definitely written as 1 upon 2, isn't it? Raised to half you can write. So what is cos phi plus sine phi equal to from here? Cos phi plus sine phi is going to be 1 plus sine 2 phi whole to the power 1 upon 2. So this particular term sine phi plus cos phi is going to become what? It is going to become 1 plus sine 2 phi raised to half. So I get my terms as here r raised to n, then a bracket 1 plus sine 2 phi raised to 1 upon 2. This is a very, very, very important step, students. See how that raised to half has been brought. It is an extensive use of the trigonometric formula. You have to be very strong with your trigonometric formulas whenever you are doing mathematics. So sine phi plus cos phi has now straight away transformed into 1 plus sine 2 phi raised to 1 upon 2. So look at this, r raised to n was already present and the bracket now has raised to 1 upon 2, bracket has raised to power 1 upon 2, and this 1 plus has also come, 1 plus has come. Now the next step, I need to get this minus 1 raised to n, and I know that the angle phi is n pi by 2 plus rx. So now let's replace that phi back over there. So I'm going to write here r raised to n 1 plus, I write sine of 2 times of what is phi. So I know that phi is n pi by 2 plus rx. So let's replace that value here. So I write here n pi by 2 plus rx, and you close your brackets, isn't it? And then this outer bracket will get closed. This outer bracket has power 1 upon 2. Now you can easily understand that the 2 which is present outside the bracket now needs to be multiplied inside the bracket. So let's multiply it inside the bracket. So when you multiply 2 inside the bracket, you get r raised to n, then 1 plus sine of, let's multiply 2 inside the bracket, so 2 and 2 cancels, you get n pi sine of n pi plus 2rx, isn't it? And this entire bracket has what power? The power is 1 upon 2. Now students, the other important part over here, you have sine of n pi plus 2rx is like theta for me. So it's 2 sine of n pi plus theta. So this 2rx I have replaced with say theta. So I now need to have the formulas for sine n pi plus theta. So observe carefully what I'm going to do over here. Students, observe carefully. If I make the quadrant system, so this is x-axis, this is y-axis, negative direction of the x-axis, and then again here you have the negative direction of the y-axis. So do you know that if a ray starts rotating along this coordinate system, here there is 0 degrees, or you can say 0 radians. Then here on the y-axis you have pi by 2. Then here you get pi, isn't it? Then if you proceed further to this particular negative direction of y-axis, you get 3 pi by 2. You proceed further, you get 2 pi, isn't it? So here you get 2 pi. Again you go ahead, you get 2 pi plus pi by 2. So that's 4 pi plus pi. That becomes 5 pi by 2. Here you get 5 pi by 2. Here you will be getting 3 pi. Again you add pi by 2, so you'll be getting here now 7 pi by 2. Again you go further, you'll be getting now 4 pi, isn't it? Again keep on proceeding further. So there's 0, 2 pi, 4 pi. Here you get pi, 3 pi. The next term is going to be 5 pi, and so on. The terms will keep on coming. So can you observe the positive direction of x that you can see? You can observe there are even multiples of pi, isn't it? In the positive direction of x-axis, you are getting even multiples of pi. This is a very important stuff, students. You got to remember all these things very, very, very properly now. So analyze these things, assimilate these things, and understand and keep them forever in your mind. So even multiples of pi are coming on the positive direction of x-axis. Let's go to the negative direction. Here you can see there is pi, 3 pi, 5 pi, and so on. So these are all what? These are all odd multiples of pi. So I write here odd multiples of pi. So you have even multiples of pi, you have odd multiples of pi. Now further, do you know in the first quadrant all trigonometric ratios are positive, and in the second quadrant sine and cosec are positive, isn't it? So any angle which is lying in the first quadrant, you will say all trigonometric ratios will be positive. Any angle which goes to the second quadrant, you will say that sine is positive. If you go to the third quadrant now, what happens in the third quadrant, students? If you go to the third quadrant, so in the third quadrant, you know that tan and cot are positive, and of course when you go to the last, the fourth quadrant, you can get cos and sec positive. Now let's get few of the terms, students. I'm going to get now the answers of, say, sine pi plus theta. That's sine of 1 pi plus theta. So this is where you can see pi, isn't it? And pi plus theta, when you take, theta is obviously maintained as an acute angle. So pi plus theta, when you take, it goes to the third quadrant. So pi plus theta is an angle of the third quadrant, isn't it? And sine of pi plus theta, it's a multiple of pi. So remember, whenever there is a multiple of pi in an allied angle, the trigonometric ratio does not change. And if you have an odd multiple of pi by 2, you can get an odd multiple of pi by 2, 1 pi by 2, 3 pi by 2, 5 pi by 2. When you are getting an odd multiple of pi by 2, then this particular allied angle changes the trigonometric ratio. Sine becomes cos, cos becomes sine, tan becomes cot, cot becomes tan, sec becomes cosec, cosec becomes sec. But this happens only when you have an odd multiple of pi by 2. Here it is a multiple of pi. So whenever there is a multiple of pi, always remember, for multiple of pi, the trigonometric ratio is not going to change. It will be maintained as it is, and the sign will be decided by the quadrant in which the angle falls. Pi plus theta, as I said, falls in the third quadrant. Third quadrant, tan and cot are positive. You are finding the answer of the trigonometric ratio sine. That's why the sine is going to be negative. SIGN, sine is going to be negative. So, as I said, multiple of pi, no change in the trigonometric ratio. The trigonometric ratio is retained. Sine again comes as sine. Cos will come cos. Tan will come tan. And you need to change the sign because pi plus theta falls in the third quadrant. Third quadrant, tan is positive, sine is going to be negative. So my answer is minus of sine theta. This is a very important stuff, students. Do not try to memorize this. Try to understand the concept and try to recall this concept. Try to retain this concept every single time. So that was sine pi plus theta. Let's take another one. Let's take one more. Let's take sine of 2 pi plus theta. I take sine of 2 pi. So this is again multiple of pi. So the trigonometric ratio is not going to change. And observe 2 pi plus theta falls into which quadrant? So this is 2 pi. And when you do plus theta, you went to the first quadrant. First quadrant, all the trigonometric ratios are positive. So the answer is going to come positive here. So my answer is going to be plus sine theta, isn't it? Let's take one more, students. Let's take one more. I now write sine of 3 pi plus theta. So again, it's a multiple of pi. So the trigonometric ratio is not going to change. Sine of 3 pi plus theta. This is 3 pi over here, isn't it? Negative direction of x-axis plus theta. If you do, theta is obviously maintained as an acute angle. So 3 pi plus theta falls into the third quadrant, isn't it? It falls in the third quadrant. So you get the answer minus sine theta, because in third quadrant tan is positive, sine is going to come negative. Let's get one more. Let's proceed further to find one more. So the next one I'm going to write, say sine of 4 pi plus theta. So again, it's a multiple of pi. No change in the trigonometric ratio. 4 pi is positive direction of x-axis plus theta. Theta is an acute angle. You went to the first quadrant. Everybody is positive. So answer is going to be plus sine theta. Let's get one more again, students. Let's get sine 5 pi plus theta. So here, can you now judge? The answer is definitely going to come minus of sine theta. So can you observe that whenever there is an odd number, the answer is turning out to be negative sine theta. Whenever there is an even number, the answer is turning out to be plus sine theta. So can I generalize this? Is it possible for me to generalize this? So I can say, in general, you can write sine of n pi plus theta as minus 1 raised to n sine theta. Whenever n is even, this will turn out to be plus, isn't it? Minus 1 raised to 2, minus 1 raised to 4, raised to 6, raised to 8. Every time this will turn out to be a positive number. And whenever n is taken as odd, this will turn out to be a negative number. Minus 1 raised to 3, minus 1 raised to 5, minus 1 raised to 7. Every time it will be a negative value. So sine of n pi plus theta in general can be written as minus 1 raised to n into sine theta. So can you now tell me what is going to happen to the term that you have in your solution, sine of n pi plus theta? So this is minus 1 raised to n sine of theta, isn't it? So theta is here 2rx. That means, students, now can I say, therefore yn is going to be r raised to n. Inside the bracket you get 1 plus minus 1 raised to n sine of 2rx raised to 1 by 2. Look at your nth derivative. R raised to n, you have r raised to n. 1 plus minus 1 raised to n sine 2rx. The same thing you can see over here. And the center bracket has a power raised to 1 by 2. That's yn, isn't it? So I've got y is equal to sine rx plus cos rx. And its nth derivative has come r raised to n 1 plus minus 1 raised to n sine 2rx raised to half. Now, the first part of the question has been done now, isn't it? I now need to proceed for the second part. So in the second part, he's telling me to get y8, isn't it? And in this y8, you put x as pi. This is y8 of pi. It simply means that x is replaced with pi and the value of r should be how much? It should be 1 upon 4. So students, let's get y8 first of all. And r I'm going to replace with what? 1 upon 4. So r is going to be written as 1 upon 4. So I get y8 is equal to, I'm replacing n with 8. So r is 1 upon 4. So 1 upon 4 raised to n, isn't it? 1 upon 4 raised to n. Then what do we have? Bracket 1 plus minus 1 raised to n into sine of 2 times of r is 1 upon 4, isn't it? Into x. So you know that you are finding for y8 of pi. So I'll change here also. I'll write pi. So x is going to be replaced with pi and this whole raised to 1 upon 2. That's your nth derivative. N is replaced with 8. R is replaced with 1 upon 4, isn't it? And finally, x has to be replaced with pi. So you can observe here this 2 and 4 cancels, isn't it? 2 and 4 cancels, you get pi by 2. What is sine pi by 2, students? Sine pi by 2 is 1, so you get 1 here. So it simply becomes y8 of pi. Y8 of pi is 1 upon 4 raised to n. In a bracket, you'll be getting 1 plus minus 1 raised to n into 1. So I get 1 plus minus 1 raised to n, isn't it? Into 1 does not make any difference. Raised to what? Raised to 1 upon 2. Now students, if n becomes odd, what will happen? If n is odd, then what happens? N is odd, the answer is going to come 0. But I know that n is given to me as 8 here. I need to find y8 of pi. That means n value is even and it is given to me as 8. So I can say y8 of pi. I will replace n also. N is going to become what? 8. So I write 1 upon 4 raised to 8. 1 plus minus 1 raised to 8 raised to 1 by 2. Now obviously minus 1 to an even power is going to be plus 1. 1 plus 1 is going to be 2. So I get here 1 upon. Now observe, this is going to come 1 plus 1. That's 2, isn't it? 1 upon 4. So 1 upon 4, 4 can be written as 2. So I get 2 square. 4 is written as 2 square and this power is 8. 1 to the power 8 is the same thing. And here I get 1 plus 1. So that's 2 raised to 1 by 2. So I'll be getting 2 raised to 1 by 2 upon 2 raised to 16. So 16 is obviously more power. So bring this half down. I know a raised to m upon a raised to n can be written as a raised to m minus n, or it can be written as 1 upon a raised to n minus m. Observe carefully, when the term from the denominator goes up, you get m minus n. When the term from the numerator comes down, it becomes n minus m. So here, this 2 raised to half I'm going to bring down. So I get 1 upon 2 raised to 16 minus 1 by 2. So that gives me 1 upon 2 raised to what? 16 2s are, that's 32 minus 1. You get 2 raised to 31 upon 2. So that's y8 of pi. So students, this is a very important question that we have seen. There was a lot of trigonometric concept involved into the solution. So getting the nth derivative was quite easy, isn't it? It was just one step, getting the nth derivative. The rest of the part, even though you can see that there are only 4 steps, but these 4 steps are based on these very important concepts. I'm very sure students you have understood this entire concept very properly. This was all about this particular question. Now let's proceed with the next type of question, students.